So let's get started. So we have folks on the conference bridge as well. So I'm going to try to speak to the. Oh well. So I'm going to try to speak to the content here. So just to kind of talk a bit about what this meetup group is about. So this group is basically for people who are looking to put AI into their startups. And so if you're thinking about building a startup that is, you trying to use AI to create a differentiated value proposition, so I try to put together a few things like, say, if your pitch to your investors says any of those things, then this is the right meetup for you. So if you're thinking that you're going to create a differentiated company because you're going to use AI, or you're trying to do some industry better because you're using AI, then that is the target, folks. Now, my colleagues and I who are running this meetup have had a fair amount of experience with building companies that do AI as well as trying to build AI on a small scale. And so that's the reason why we created this meetup, is because we kind of firsthand know what's involved in that exercise. And so this meetup is really about trying to help people to come together to discuss those common problems that come in when you're trying to create a startup that uses AI. So some of the common problems that we've seen, that people run into when they do this is, first of all, how do you create production grade AI on a small budget? In a startup company, for example, unless you're natively a data scientist, hiring a data scientist can be an extremely difficult task. They're expensive, they get a lot of competitive offers. Sometimes it's just hard to convince them that your company is the right place for them to be, things like that. And so one of the questions many people have is, okay, I can't even hire a data scientist. How am I going to build an AI, or how am I even going to convince a VC that I have the ability to do this? When I can. Yes, please.
Can you take photograph?
Oh yeah, by all means. And the session is being recorded, and I'll post it as well on the meetups listing. So that's the first thing, which is, how do you even get started? Second is, in order to actually make use of this, this kind of, AI, you're welcome to take photos of the slides. I didn't say you could take photos of the attendees, please. Okay, that's not appropriate. Okay, please don't take photos of the attendees. That's not, please delete them. Okay, you're welcome to take photos of the slides as much as you'd like.
Yeah. You're sending the slides anyway, right?
Huh?
You're sending the slides anyway.
I will be posting the video, so you don't have to take photos. If you want to take photos of the slides, go right ahead. Please don't take photos of the attendees.
No, that's fine. We're taking the points now.
Yeah. So, so first thing is,
Yeah, we don't want our companies.
Yeah. So,
We don't want companies to know that I'm here.
that too, I guess. Yes, there are many reasons for this. Yes. Yes, you don't want your boss to find out that you are an AI entrepreneur startup. Yes, no, I agree. Please do delete the photos. I would appreciate it if you do. So these are some of the examples of problems that we've seen people, engage with. And so maybe kind of a good time to have a little bit of discussion around the room, since we have, a nice small group here. Can you tell us a bit about why you're here? Where are you in this startup journey? Want me to start?
I'll start with me. I'm in the very beginning stage. Okay. The couple of questions I'm trying to address is most travel sites.
Yeah, by the way, we are together.
Oh, okay.
Yeah.
That explained why you weren't taking photos of him. Okay. Yes.
Most of the travel sites have two issues. Issue number one is they're very bad in secondary destinations.
Okay.
And remote destinations. There's an interesting article on New York Times on this. She wanted to go to some place in Cambodia and found that the best way is to go reverse. Reverse. Okay. So there are a number of heuristic rules that are coming in case of travel sites. Now, things like Amadeus and what is the other equivalent of, they allow you to give you a few things of what is the future pricing and stuff like that. Now, most travel sites, what is these amendias, things like that directly. And they don't have an intelligent.
Okay.
We want to put in some algorithm and some heuristics on the top of that search to search better.
Okay, makes sense.
So we want to keep a history on this and search better. The question is, take the history. From the history, how do you search better? And I want some kind of data science to this, find out any trend or things like that.
Makes sense. And other folks, I mean, you don't need to discuss your startup idea. Like, I'm mostly kind of trying to understand
Sorry,
where are you? No problem. Where are you in your journey, as well as what are the problems that you guys are running into, and what are you looking to get out of this meetup?
My objective of being here is to learn AI.
Okay, fair enough.
So at a very basic level,
Mhm.
try to understand at a more fundamental level what it can do, what it can't do, answer some of the questions you've got there with say that are about the problem, false expectations, or they expect too much.
Okay, makes
True
sense.
AI, machine learning, full background.
So, yeah, just like him, basically, I'm here, basically, whatever startup ideas we have, like how to, because that's what the subject also says,
Yes.
right? How to bring in AI
Into the problem, yes. Okay,
So
fair enough.
that's the right, and things like that. I hope you will see that. That's
Yeah,
right.
basically, we want to learn what the thing is.
Right, what
We
the
had
thing
some,
is and what you can do with it, right?
All we know is we're playing with
And then
TensorFlow.
we'll investigate how to incorporate it.
Makes sense. Sorry, you were saying?
Along the same lines of learning, but this one seemed interesting because it was like, how can I do it without being Google, right? Like, how can
Yes.
I do it on a small scale
That
and
makes sense.
still, leverage this technology? So
Makes
that's
sense.
pretty
Right,
interesting.
Nisha, what you said is very true, the way you started is like,
Mm.
first get a data scientist. Well,
Mm.
yeah, okay. Couple of 100,000.
Exactly, right? And that's, unfortunately, that's kind of non-viable for a lot of people if that's where I have to start.
Mhm.
And the thing is that VCs know this, and so they will ask you some critical questions. If you go in with a pitch that says, I'm going to use AI, the first question is going to be, how in the world are you going to hire one?
Mhm.
And you need to have a
Who on
viable
your
answer.
team is an AI?
Who on your team is an AI, and this is actually very important. So yeah, so this is one of the issues, and so this, yeah. And then other things come down to, how do I even, like, there's so many tools out there, there's so much tech out there, but it can become very overwhelming to kind of get started. Would you like to make a comment?
I'm here to learn as well.
Okay.
My background is mainly in fashions and beauty products and consumer brands. So I would like to know how the machine learning can how marketing size,
Oh,
or,
interesting.
customer journey and stuff like that. So exploring ideas, maybe how even customer service and all of that stuff. Yeah, just get to learn.
Okay. So we're just discussing kind of what you're looking to get out of the meetup. So if you have anything you'd like to say about specifically, like what are the issues that you're having in your startup journey, or what would you like meetups to cover?
I just want to listen.
Okay, sounds good. Yeah.
That's most of the position is we want to listen and learn.
Okay, sounds good. And we are more than happy to talk. So there's quite a few people on the bridge. So I will basically not ask them to necessarily speak because it'll be a little disconcerting for them. Yes. So my name is Nisha Talagala. Nisha Gupta is my married name. I go by both. So I am the CEO of a company called Pixida. And what we, Pixida, Pyxeda.
XED.
Is it a startup?
It's a startup company.
XEDA.
Yes. And basically, so I'm one of the founders of this company. Swami over there is our other
Right.
founder, and Sindhu is our head of machine learning, and Shilpa works with us as well. So we all work for the same company. And what we do is we basically have created a SaaS service that makes AI accessible to people with practically no math or no programming knowledge. Now you can add math and programming as you proceed if you want to get more sophisticated, but you don't need any math or programming knowledge to build AI. And the reason we've done this is because we've been in the AI space for many years. We actually previously had an AI startup that was acquired. So this is our second AI startup. And in our previous company, we actually helped enterprises, scale production grade AI. So, they have an entirely different set of problems. But one thing that we kind of realized with our experience has been that that it's just very hard for people to get started. Even enterprises have a hard time getting started. And frankly, the process of hiring and building an AI team is extraordinarily, messy on like many different levels. Everyone's got a horror story, and we have a few, right, of how expensive these teams are, how hard they are to integrate with the rest of the organization. Like one of the startups that we work with, one of the stories that he used to tell me is he hired a data scientist who was a PhD out of Stanford, cost more than all of his other employees combined, and then spent like 2 years trying to figure out how to work with the guy, and then had no choice but to let go of him. And it's not because these people, that data scientists are difficult to work with. It's that, they come with a very specialized skill set. It's hard for them to be successful if you don't know how to, support them with the right skill set. So sometimes even if they are capable, a small organization, for them to become successful is just hard. Things like that. And so one of the reasons why we created this product is because AI is becoming one of those technologies that frankly everybody needs to become somewhat competent in. And not necessarily meaning that you need to know all the math, but you have to be able to use the tool. You have to be able to say, okay, if I have a problem that can use it, I can identify that problem. If there's a problem that is not suitable for AI, I can identify that too. So part of a good tool is to know when to use it, right? And feel like you're able to kind of command it as opposed to the other way around. So you know what it can do, you know how to manipulate it. You can identify problems when they can be, can benefit, you can bring it to bear to benefit, and then you can put it into production and actually use it. So we'll show you what we built a little bit later, but the basic idea is we're trying to create a scenario where people can start with none of that knowledge, and then proceed as they go forward. They can add as much of that knowledge as they like. Because for example, if you're building a startup company that's going to be reliant upon an AI, and say you grow really big, you're going to want your own data science team. You're going to want your own, massive organization that is going to create custom algorithms. So starting with none of that knowledge is a place to start. It doesn't mean you want to be there for the rest of your company's life, but what you want is a path, as opposed to feeling like there's no way to get started. You want a path where you can start with very little and then grow to whatever level of investment that you want to make. So that's the kind of the target that we have.
If possible, and if you are willing, and if there is time, could you tell of your case story in the meeting or sometime later, so have an idea how the
we'll demo you one, for example.
Journey is like.
Yeah, we can tell you a little bit about the case study. Yeah,
so I'm really confused. So your company is training people, or is like you can build products as according to the enterprise needs or something? I don't know.
So we provide a SaaS, a software as a service, that makes it easy for people to build AIs.
Okay. So
We also train in certain cases.
Is that online course or something?
We have some online courses. We have some, we can point you to one of the online courses we're running right now. For example, we have custom consulting, but it's all around the fact that there's a product that makes it very easy to do. So we don't train people on how to use AWS natively, for example, because that's a fairly hard process. We don't train people how to do that. We provide a tool that makes it much easier, and we train people on how to become effective with that tool if they need or want the training. Some of it can just be done by yourself.
This tool is sitting on the top of TensorFlow or something equivalent,
It's sitting on top of a large range of cloud tools.
Okay.
So you can, for example, use your own AWS account.
Yeah.
And you can bring in your AWS account. You'll be using AWS tools. It's just that it'll take you minutes to build one as opposed to hours. And so we can show you that.
We'll
show you that. So
you wrote a tool on the top of AWS.
Or on top of multiple clouds.
Multiple.
Yeah.
Would you have an underlying AI engine or something?
So we have several underlying AI engines. We use SageMaker, we use some custom code, things like that. We provide a range of different algorithms.
Starter subscription to play with? Or?
Absolutely, yeah. Yeah, we can show it to you, In fact, do you want to show them the slide where we have the starter subscription?
It's later.
Oh,
it's
okay,
fine.
we'll show it to you
Yeah.
later. By the way, this thing is not working for me at all.
Remember that we are all here to learn and we're going to ask you the questions.
No, you're welcome to ask questions. I'm just having some trouble with my laptop.
Yeah, IT guy will take care.
Okay.
Very less,
Yeah, no, please ask questions. This is a meetup, this is not a...
Is it a meetup, is it a series or like it's just one meetup?
No, so I would like to have a series.
Oh.
One of the reasons why I listed these questions is because obviously we can't address all of them here. We'll start with a bit of an introduction and a bit of an overview, and we have a section later in the meetup where we will kind of explicitly solicit more inputs. What is going on? Can you click on? Nope, it doesn't work.
Is this the first in the series?
This is the first in the series. Okay. So now it's good. So what I was going to say is that this is the first in a series. There is actually a section later in the meetup where I'm explicitly going to solicit ideas for follow-on meetups. So if you have specific topics. The other thing is that if you go to the meetups list, you'll find that there's a survey link there. And the survey link is mostly asking you what kind of problems you'd like to see discussed. So if you go to the meetup and go to the discussion, there's a survey link and it asks you things like, what are the biggest problems you're having? Also ask you some logistics questions. Do you like meeting on weekends, weekdays, online, offline? It just helps us to create better events. So if you haven't had a chance to, please go ahead and take a look at that and fill it in. Oh,
when you come and sit here.
would you like to come and sit up front? Yeah, please. And
Can you stop sharing and start sharing again? I think looks like your screen is frozen.
yeah, my screen appears to be extremely unhappy right now. Sindhu, maybe the right thing to do is let me share and why don't you project? Because that way I can have more control over it and you can just project. The bulk of them are thinking about it, and a good chunk of them are still, production and above is over here. So it's only about 30% of the people in the meetup. Then this is the question was asked about what is the problem that you're having. All these guys are basically saying they don't have an AI person in the team, in one form or another. And so they just don't know what to do. Oddly enough, nobody said that they don't have any data, which is, surprising to me because one of the biggest problems that people have when they try to build an AI startup usually is a lack of data. So I'm not quite sure what to do with that. This group is having data, but they don't quite know what to do with their data. So they've got a bunch of data, but they haven't built a model about it. They don't know how to attach it with the AI. And these guys are like, they have an AI that seems to work, but they can't figure out how to get it into production. So that gives you a sense of the kind of problems that you run into. And in some ways, that is the natural course of events. So you start, with a contemplation, then you have to get some data, then you have to figure out whether your data is telling you something about the AI. So like say that you want to go to a VC and say, I'm going to use AI to disrupt this industry, this multi-billion-dollar industry. I'm going to do it better because I have the AI. First thing they're going to ask you is, how do you know that an AI is going to help? Second is, where are you going to get the data to create an effective AI? If you have those two, then the question will be, how are you going to get all of that AI to work in real life? So that's sort of the sequence that you kind of go through. And so the first problem that you'll probably run into, unless you're a data scientist natively, is the lack of the expertise. The second problem you'll probably run into is the lack of data. So any questions on that one? So what we will cover today is we'll give you guys a basic overview of the AI lifecycle, of the process that you will need to follow if you try to get a production AI working in real life. We'll tell you a bit about some of the tools that are available. We'll tell you about a very common and really powerful method for deploying AI called microservices, which is available to everybody, and it simply just makes your life just so much easier, and would strongly recommend it unless you have a really good reason not to do things that way. It's what I would recommend. We will do a quick demo. This is what we talked about. We'll do a quick demo of what it means to build one and try one, and we'll show you where you can sign up for a free subscription. Then we'll have a quick discussion about follow-up meetings and what kind of topics will be worth discussing, because each of these topics, unfortunately, is a topic in itself. Like we could spend hours discussing how hard it is to hire data scientists, some of the tricks that we've done in the past to hire them, what it takes to make them effective and things like that. So each one of these topics is a meetup worth its own. What I'm trying to get is a sense of what are the most pertinent problems facing the group so that we can order the order of the discussions. Yes.
We are also software engineers, so how difficult is it to pick up some basic and expertise to start doing our work? I mean, I've played with TensorFlow, the number recognition game, which everybody has done, and I think unfortunately it stops there.
Right. So we honestly, it's not that hard, if you have the right tools in place. So
you can download TensorFlow from anywhere.
No, but the question is, but downloading TensorFlow doesn't put a model into production, right? Right. Yeah. So the problem. So one of the problems that I don't know, Sindhu, if you want to weigh in here, but one of the problems with learning AI is that there are test cases like the number one that are really not that hard to do at all.
Yes.
The problem is taking the next leap.
Yes.
Right. You do the test one, and but now what? Kind of thing. What has it told you about your data?
Yes.
Are you in any position to do anything about your data because you've done that exercise?
Yes.
And that's what
numbers have run characters, and that's it.
Exactly. So the problem. Yeah. Then what? Right. Yes. And so half the battle is. Yes. So this is one of the reasons why we built the toolkit that we did, is because there's lots of stops and starts in the AI deployment process right now. There are exercises. They work very well as learning exercises, but they don't help you get going in the real world. So if you're taking it in a class, that works just wonderfully, but, in order to actually deploy something. So for example, for your problem, it's not at all clear that recognizing numbers is going to help you.
No. We have to figure out what I need.
Exactly. So the point is that.
What is the future projection do we need?
Exactly.
First we have to answer this question is that, okay, as the current today's data, what is the future projection is going to see? What are the future projection is one of them.
Yeah.
The other one that's more weak, but
yeah,
future projection is what we need, and how to take the data to create the future projection is still in thought.
Exactly, and this, by the way, is a very common problem. So, for example, if the problem that you're having is about making future projections from data, it's quite possible that what you have is actually a time series forecasting problem.
What?
Time series forecasting. It's possible that that's what you have. It's also possible.
For the time being, yes.
It's possible. It could also be a variant of a classification problem. It could be a variant of a regression problem.
What is the thing called time?
Time series, classification, and regression. So the basic, what I'm trying, generally trying to say is that there are many, many different types of AI, and doing an exercise in one of them doesn't help you with many, many serious problems, like taking your data and trying to figure out if the one that you played with is even the one that's right for your problem. So there's there's this task of what kind of AI is right for your problem. There's hundreds of different kinds of AIs.
I'm not in denial that there's doing number recognition and character recognition.
Oh, no.
I'm possible. I'm not, absolutely, I don't have
no, I know you are not. I'm just saying that this is actually a very common and pervasive problem. And this is one of the reasons why people struggle a lot, is because there's this big gap, not just for you, for practically everybody, that there's a gap between the exercises and the issues that you face in the real, of solving a custom problem. So that's one of the things that we'll try to cover today. Sorry, yeah. Okay, yeah. So this is a basic workflow, and I'll go through this because this is a workflow that, honestly, we didn't develop. You'll find variants of it all over the internet. Most people follow it. They may call it a little bit differently, but it's actually worth keeping an eye on it because you will follow this kind of thing. So the first thing is that you want to identify a business need or your problem. What is your problem? Then you have to gather data for your problem. You have to use that data to create an AI model. And by the way, between here and here is where you kind of decide what type of AI you might need. Then once you have a model, then you have to kind of train it and test it to make sure it's any good. After you've tested it, now comes an entirely different scenario, which is now, okay, say I have one that works. Now I actually have to put it into production. I have to put it in a place where it can solve new problems. And what you will find is that most tools out there stop about here. That they really, most people are preoccupied with the training. And deploying is unfortunately how you make money out of it. So things that are trained are kind of like academic courses that didn't get you a job, right? So this is deploying. And then once you've deployed it, you have to connect it to your business for your business to benefit. And then you have to figure out whether the whole thing is working. And what you will find is that, like many things, this is iterative. You'll find that there's something wrong, and then you'll do it again and again, and you will continue to do it over and over for the life of your business, every time making it better. So there's this cycle, and you basically repeat this cycle multiple times. And so if you talk to, big companies like LinkedIn, you will find that they have run through this cycle like hundreds of times for each of their major things, each time trying to make it a little better, refining the data, refining the problem, everything in between. So then question becomes, hold on a second. Question becomes, so why is it that we have to focus on the full workflow? Well, the first thing is without the full workflow, you're not actually going to be able to put the AI to use. And until you put the AI to use, you cannot actually get money out of it. You also won't be able to tell whether the AI is having a positive impact on your business unless you actually try to use it. What's going on? Oh, that's yours. Okay. Okay. That's also how you show return on investment. Now, why is this challenging? It's challenging because, frankly, there's like 8 different steps in here. And what you will find is that many of these steps have their own tool. And so part of it is that you have to kind of recognize how to get 7 or 8 tools to work together in order to perform the end function. And this is one of the reasons why it's hard for so many, for people. It also means that it requires a different levels of skill sets. So for example, the data science skill primarily specializes in these 3 buckets and a little bit on this bucket. That's where the primary training of data science lives. It does not often help you on any of these things. These 2 areas, probably more the purview of a business analyst. So part of why it's hard to, actually get this full cycle working is that it requires you to understand the business, understand the data, understand machine learning, understand how to run a production, understand how the production is working, repeat the whole thing over and again. That's usually like 5 people in many companies. And so in a startup, fortunately, chances are they're all you and you're not fighting with yourself. So that's actually a good thing. But on the other hand, it does mean that you need to know a lot. So then I think for, those of you who are coming up to speed with AI, one thing to kind of remember is that no matter how daunting it might seem, for a very large fraction of AI programs, there's really two basic steps that you need to know. They train and they predict. So training is when they learn, prediction is when they use what they've learned in order to answer new questions. And there are variants of AI that do not follow this basic model, but this model, is used by a large majority of them. So you will go a very long way if you just structure around this. And but there are many sophisticated ones that are much more complex than this. But this will take you a really long way. Let's put it that way. So the basic idea is you get example data, you train, out comes a model, which is a bunch of numbers. You push that model into a prediction program, and that prediction program takes in new data and predicts answers. So in order to get an AI to work, you have to get some data, you have to create this model, which is the process of training, and then you have to build yourself a production grade prediction program that can answer questions every day for your running business. So as a simple example, say I wanted to use an AI to guess a person's mood, which is kind of like sentiment analysis. So practical applications of this is I may want to do customer optimization, try to figure out whether I have happy customers or unhappy customers, whether I can use that in sales, things like that. I create data, which is examples of, in this case, the happiness sentiment and the sadness sentiment. I train on that data, I have a model. I plug that model into a prediction program. I come in and type in a new thing, which is say I say I'm feeling great. It will predict happy. Or I say I've had a very long day. Predict probably sad or something like that. And so this is a very, very simple example, intentionally so, but it shows you the structure that will be followed by most AI programs.
But it doesn't learn angry and those things.
Oh, so you can structure it to learn whatever you want. So right now, this is saying it's been structured to learn happy and sad. If I wanted happy, sad, angry, despondent, then I would have to structure it that way. So part of setting up the data is to basically set it up so that you define what you want to learn.
So it cannot do more than that.
It cannot do more than that. Fair enough. Yes. So the basic thing to remember is that it's effectively AI programs for the most part are mathematical programs that map patterns, and they will map patterns in pretty much the way that you've asked them to. If you ask them to choose between happy and sad, they will map everything to happy or sad, or I cannot map. Those are going to be the only options. If you want something else, then you have to program that in. So that's, a kind of an example. And so this, by the way, is a very simple example of the type of AI called classification. So it classifies between happy and sad. And it is a binary classification because it only classifies two things. It doesn't have to be that way. It can be a multi-class classification where it does happy, sad, despondent, excited, or anything else. So now let's talk a bit about microservices. And I wanted to describe this about microservices because, for this particular, audience, given that you're interested in building applications that use AI, this is very important. Do folks know what a microservice is?
Docker and stuff like that.
Docker is a container, can be used to use microservices, absolutely. Hi, come on in.
Microservice basically, as the name indicates.
It's a microservice, yeah, absolutely.
Basically, break up earlier it used to be like that, then they went to the SDN model, distributed,
Yes.
And then made centralized. Again,
Exactly.
Centralized doesn't work,
Yes, exactly. Yeah, makes sense. So a microservice is basically, think of it as a program that is running that does exactly one thing. So imagine if you're trying to, say, build a large application and it did 7 or 8 things. What you could do is you could write one program for each thing and then connect them together. So the basic idea of a microservice here is one easy way to use AI is to say that the AI itself, its job is to answer questions. So in the previous example, for example, it takes a sentence and comes back happy or sad. That is the entirety of what it does. Now you are going to use that in an application to do something much more interesting and much fancier. But at the end of the day, the AI's job is it takes information, comes back with a prediction. That's all it does. So if you think about building that AI as a microservice, what it means is it can be running in a program anywhere in the cloud, and you can connect to it with your application really easily. Because all you have to do is to point to it, ask it a question whenever you want an AI infusion into your program, get the answer and work off the answer. So the microservice model is really nice because it completely decouples the AI from your application that you're building for your startup. You know, the AI can be running all the time. You can retrain it whenever you like. You don't have to change the code of your program. You can write your program in any language you like. And as long as you just connect to the question and get back the answer, you have this really easy way to integrate. So what we are going to show you today is how to integrate an AI as a microservice, because it's just a super, super powerful and easy way to do it. Now, why would you not want to do it? One reason is if it's not fast enough for you. So there are some things that have to predict in like 1 millisecond. This will probably not work. There are some cases where maybe you run the AI like once every 3 months and you just want to give it an enormous task. Like, I want you to make 300,000 predictions, come back with 300,000 answers. They're probably not the right way. You know, so, but for the vast majority of use cases, this is just a really simple way to get an AI working. And it also goes a long way towards creating a connection that you can manage. Because then you know what you're calling, you can stop calling it at any time. If it goes down, you know, the rest of your program doesn't crash with it, things like that. So what we will demo for you today is a microservice pattern. And if you guys are interested in further details about that kind of thing, we're happy to, you know, have a follow-on session about it. Yes, please.
So can I understand that, like, so the whole West API thing is like a huge library of all kinds of microservices that you can, like, people already build. So you can like gather those together to build a specific application that suits your need, right?
So the REST API is actually just a language to talk to the microservice.
Oh, okay.
Like, say I'm a microservice, right? And I'm running in the cloud somewhere and I've advertised my access point. The REST API is how you would talk to me. You would send your question and I would send an answer. So the REST API itself is not a library of microservices. It's a library of communication.
Then you have to like build all sorts of microservices.
So you would have to build the microservices. So what we'll show you in the demo is how to build a microservice that does an AI. And then we'll show you how to talk to it. So the way to think about this is, say you want to build a startup that is going to use AI for something. You will train your AI. You will create a prediction program that runs as a microservice. And then you will build the rest of your application to talk to it, ask it questions, and get back answers.
Isn't it a lot of work? Like, one microservice is supposed to be on questions, and then you have to have a lot of to make one application work.
So what happens is that, think of it this way, you know, the reason that, so this is actually the pros and cons of the microservice is exactly what you said. So it's kind of like the double-edged sword there. If you make each question a separate service, then you do have to connect a lot of services. On the other hand, if one of the services fails, it doesn't take down the other ones. So the alternative is to create one gigantic thing that answers all the questions. And if it dies, it all dies with it. So the reason people like the microservices is because it's an easy way to add something. Like, say you already had an application and it didn't have any AI in it, and you wanted to add some AI. This is a really easy way to do it without changing your primary program a lot. Because wherever you need the AI, you just ask the question. Now, if you have 100 AIs, yes, then it becomes really unpleasant. So it's a very good way to kind of get started and get moving. But one of the pros of a microservice is that it's very easy to manage when you don't have too many of them. The cons of a microservice is if you actually do have hundreds of them, then managing the microservices themselves becomes a big headache. So it's a good way to get started. It's something you want to keep an eye on if you find yourself building a lot of AIs. Then it can get tricky. You know, and there are ways that people, you know how to manage a lot of microservices. You know, there are pieces of software out there that'll just help you manage your microservices. So there are people who do that. But your point is very valid. So that's kind of the trade-off there.
So isn't it somewhere like a library that somebody already built it, so you can like learn this, or you can like do a little bit of your things to change it a little bit, but they have the model happens there.
So there are many. So there's many AI APIs. Like, for example, if you're doing image recognition, or you're doing facial recognition, or voice recognition, or natural language processing, you will find that there's quite a few APIs out there that have been mostly trained, but you can add your own.
Where can you find this kind of?
So you can find them on places like Amazon. You can find them in all the cloud services have them.
Google is known for.
And they are usually for things that you can find to be fairly generic. So for example, if you wanted to build a chatbot, there's no need for you to build one from scratch. Lots of people know how to do it. So if you wanted to add a chatbot to your website, for example, but if you have a unique problem that you're solving, like you want to do something with AI that's, that your data is unique, then you have to train your own.
Based on that.
You build based on that.
That makes you faster. Right?
Exactly. So simple things like, say I wanted to recognize faces. There's no need for me to build a facial recognition from scratch. Chances are someone's built one. I might want to add to it to recognize my family. But I don't need to teach an AI what a nose is. Someone's already done that, right? So in the areas of facial recognition, certain kinds of image recognition, chatbots, things like that, you will find APIs, as he said, in the cloud that solve a lot of CAN problems. But if you're building a startup and you have a non-CAN problem, then you probably want to build your own. I think there is a couple of questions on the chat, so let me take a quick look at them. Okay, to Ravi, I will answer your question in just a second once the demo starts, because Sindhu will be presenting the demo. Just hold on just a second, okay? Okay, so cloud services, someone was describing the cloud services. This is a picture of not all the cloud services offered by the 3 major cloud vendors. And this picture does not have all of them. I'm guessing it's missing about 50 or 60 of them. So the short answer, and this is just the 3 major cloud vendors. So the short answer is there's no more need for tools. The problem people have is not the lack of tools. The problem people have is that mapping the tools into something you want to get done is fairly challenging. Each one of these is a separate tool. And they're all very powerful. It's just that the place where people struggle is exactly why, when do I need it? How do I bring in what it needs? How does it talk to the other tool? Where's my data? How does any of this talk to the data? Stuff like that. So this should give you a sense of just, how, many tools are out there.
Is there any consistency across cloud vendors of the tools, or they all have different implementations of the same thing?
They all have, no, they don't provide there's no standardization yet in the AI space. So the value chain is not clearly defined. So 2 tools from 2 different vendors do not do the same thing. They do slightly different things. And the further up the value they go, the more different they are. Sorry?
Where's your tool here?
No, we basically provide a layer above these. These are provided by the 3 major cloud vendors, not by us.
So they're made by the cloud vendors.
They're made by the cloud vendors. These are all the tools that are made by the 3 cloud vendors, short of the last 50 or so that they announced over the last 3 months.
What is GCP? Google Cloud Platform?
Google Cloud Platform,
AWS,
Amazon Web Services, and Azure. This does not count anything in open source. It doesn't count IBM, SAP, Salesforce, any of the private vendors. So you can imagine that there's a lot more than this. This is mostly meant to be illustrative. It's illustrating that there's a lot of stuff out there, but this is also what makes getting started with it harder.
Okay.
There's a lot of stuff out there. And unfortunately, because the value chain has not standardized, it's not like I can say this one from Google is the same as this one from, Amazon is the same as this one from Azure. They're not interoperable. They're not necessarily interoperable within themselves, and things like that. So now, if you want to,
I met a guy, their customers use all the 3 clouds.
Yes.
Cater to that.
Yes, multi-cloud is becoming a thing.
How do you know which one to use?
You don't. That's the problem. Therein lies so that's the reason we created the tool that we did, is because it's very difficult.
So
it takes very much.
if I use your tool, then my application or microservice sitting on your tool can be taken from one cloud to another seamlessly.
Yes, that is our, that's basically the target of what we're doing. Yes. So now, if you wanted to build and use an AI workflow in the cloud, you need to find tools to do the following things. So first of all, you need some infrastructure. You have to run, your compute somewhere, and you've got to put your data somewhere. Secondly, you've got to have labeled data. So labeled data means the AI cannot learn. If you're using a supervised AI, which is the vast majority of the AIs out there, they need to know what the right answer is for training, which means you have to label it. So in the case of example we showed earlier, any sentiment you have to label it. This is a happy sentiment. This is a sad sentiment. You have to have lots of examples, so you need labeling. Then you have to prepare the data because AIs don't take data in standard formats. They take them in very specific numerical formats. So that's important. Then you have to find a model and train it. Then you have to deploy it. And then you have to essentially get your application to ask questions and get predictions. So you need to build this stack into your infrastructure in order to get your AI to be production functional. And this doesn't say what software to use. It just simply means these functions have to occur in some form or another. So what we are going to do today, right now, is Sindhu is going to take over in just a minute, and she's going to show you how to do a version of this stack. And actually, I think we're going to show you data prep and visualization. Does everyone here know what churn is? It's just an example that we're going to run through. No. So churn is a very common business problem where the basic idea is you're trying to figure out if a customer is going to leave your service or not. So say that you're a bank, and I think that's the example we're going to use. Okay, we are going to say, okay, is this customer going to leave the bank or not? So the prediction we're trying to make is a binary, yes or no, leaving the bank, not leaving the bank. The information we're going to use is everything from what is the income of this customer, how long have they been with the bank, do they have a credit card, pretty much anything that we can tell about it. And then we're going to try to train the AI to determine whether or not they're going to leave. So this is a very common business problem. It occurs in almost every business, and it occurs sometimes in large companies where they're trying to figure out if an employee is going to leave. So very common standard problem. We're going to follow this stack for it to show you how you build an AI to do this. And in order to get this in production, it means that people have to be able to come to the AI and say, okay, I have a new customer. Here are all of his details. Is he leaving or not? And if he's leaving, you panic and you offer him something special. Or if he's not leaving, you don't panic and you go along your way. So that's an example. This is done with an open source data set. So you guys can actually try this out yourselves if you want to. The data set is right here. And you can download this data set and upload it and actually build your own AI, as you see fit. So
data set means, does it include model also?
No, this is just the data. This is past examples.
But data would be like customer's data.
Well, this is a sample data. So, so effectively think of this as this is a data set that somebody put together a while back and made public.
Where does the model come from?
The model comes from the training. The model will get created right here.
Oh, you give the data and you train it, then it creates the model.
It creates the model.
Output
exactly.
Is the model.
The output of the training is a model.
And then you use that.
You put it into the microservice, and that's how it makes predictions. So, any questions there?
Is that really a binary? Isn't it more like a probability, like this customer?
Oh no, it could be. You can phrase the problem in a lot of ways. So we created a binary just to make it simple for the demo.
Okay.
So if you want to do a more sophisticated one, absolutely. You might say the probability
But
that
you have to set, like, to get a binary, you have to set a probability level, 80%.
Yes. Yes.
Something like that.
Exactly.
Okay.
So one quick question I have. In the data, do you mention that, let's say in the banking example that, okay, such and such customer with, these many credit card relationship or not has left or not left. So does it have the actual result in the data or that's not there?
It has actual result in the data, yes. And so when we show the demo, we'll show you, but absolutely. And you're raising a very important point, which is in supervised learning, you do need past examples where the true answer is no. So the way you would gather data for something like this is you will gather data for a while and then say, okay, here's the characteristics of the guys who left. And here's
how many attributes are the right amount of attribute to have based upon which you are getting the results? Like you can have like 10 attributes, or you can have 4 attributes. Like how do you decide the right amount of attributes?
Sindhu, you want to weigh in?
So that's a really, really hard question to answer. There is no true, value for it. It depends on your application. In some cases, having just 5 attributes is also enough. It depends on how complex your problem is. I can give a mathematical explanation. I don't know if it's going to help.
So I can also add
So basically,
use as many attributes as possible, and then the machine learning will select which attributes are more meaningful, and based on that, you can train it actually. The simplest solution is to get as much information as possible to train the best possible model.
One of the data where the standard deviation is high.
So
not necessarily.
is high. The standard deviation is low than what is high.
So you're saying that there is an algorithm that will weigh the model, the attributes, and then say which one is a meaningful and which one is not meaningful, and then
So
you keep the meaningful one. And
yeah, absolutely. So there are some algorithms that will do that. And actually in the data sets that we are showing you, there are some analysis that you can do while the data is being prepared that tells you whether some attributes are just not useful. So there are some attributes that are just not useful. In real world scenarios, you will find attributes anywhere from single digits to hundreds of attributes. But generally speaking, if you're starting, it's better to start with a few just to wrap your brain around what's going on. The feature engineering processing can tell you when some of the attributes are really similar and possibly working, but Sindhu's ultimate answer is the right one, which is it really is an art of experimentation that is unique to your problem. So this is also the reason why this process is iterative. The reason the process is iterative is as you go through it, you learn more things. And frankly, you may find that after you do the first one, you've discovered more information than you had. Like as time goes on, you get more information, right? So that's the reason the process is iterative is you keep retraining with new data and you start to get better at it. So sadly, there's no good answer to that.
and basically, so I think the training depends upon the data. So the data purification is very important. That we have the right data to train the model, right? So maybe that comes into the data engineering part. But how do you typically pick the data? In this example that you're giving, it's already cleansed data, right? So
actually, it's not fully cleansed. So we'll show you how it actually gets cleaned as well.
Okay.
Yeah, but your point is valid, which is the data cleaning is a very complex and important part of it. What we've created is a path for you to get some basic data cleanings that are, that can be automated for you. And then kind of start with that, but then we also provide you with some guidance as to what features are more important, things like that. So
thank you.
Just to help along. No, I appreciate it. Those are really good questions.
Do you have in your workflow? Do you have places to insert customization? Like
we
don't cover?
Absolutely, yes.
Okay.
We can show you that as well.
Okay.
Absolutely. So I think Sindhu, the next step is the demo. So if you want to go ahead and demo. Yes,
I
please.
have one question. So it looks like here training is also one of the main important steps.
It is, absolutely.
So the trainer, what is it? Is it software? Do we write it, or as a data scientist write it, or what is it?
So typically, the data scientist.
Like these days
So most of the time, the data scientists do not write the training. There are many, many different powerful algorithms out there and the training programs are already out there. Usually what a data scientist does is pick the right one and run it with different ways until they like the outcome. No, I mean, this is, and by the way, that's a seriously non-trivial thing to do. So it's not an insult of data scientists. It's just that I guess the way I would think about it is right now, there are so many algorithms out there. The likelihood that you'll need to write a new one is extraordinarily low.
Yeah.
it's not even possible.
I mean, it's not impossible, but I wouldn't do it unless,
Even the source code of them are available.
I'm just saying they're all available. They're all in source. They're all very powerful. There are so many different ones. They usually know how they know about these algorithms, and they've usually had experience using one or other of them.
Are these open source?
There are many open source algorithms, not all of them open source, but there are many, many open source out there.
People deal with algorithms. Is it pretty, like, is there new?
Oh yeah, there's new
coming
ones
up?
coming in every 5 minutes. Yeah.
Oh, really? Okay.
Yes.
That's still a lot of change happening.
Yeah.
Okay.
A stupid question. So now that we are asking such basic questions, let me ask another basic question. Okay. So I have a training data. See, I have got 100 of them. But just a number. I take the last 10 for the final exam.
Yes.
Okay. So I put in the 19.
Uh-huh.
I create some training model.
Okay.
And then I put the last 10 for the final exam. So do I pass or not?
Okay.
And I fail.
Okay.
What do I do?
Depends on what you mean by fail. Why did you fail?
See, I have got, it's a labeled data.
So you got an accuracy score that you didn't like.
I got an accuracy score I didn't like.
Okay, that's what you mean by fail.
Okay.
Well, so there's a couple of things you can do. First thing is you can try to get more examples.
Okay, more data.
More data.
Okay.
Never a bad idea. to get more data.
How do you know that data is not junk?
You pretty much, that is for your judgment. You know, the algorithm can't tell you. So the data has to be representative of your problem, right? So you know, if you're going to try to solve a problem, then the data has to be representative of the problem that you're trying to solve. If not, then it's basically, there's nothing anybody can do about it.
So there are a lot of things. So let me give you an example. Let's say you're trying to predict the price of a house,
Yes.
right? And then you realize that your algorithm is not doing a good job at it.
Yes.
So there are a lot of things you can do. You can look for additional features that may help you. You can look for more samples which may help you. Now it can happen, none of these things help you. Then there are
you meant attributes.
more attributes.
More attributes.
Now maybe nothing works, right? Even if you collect more features, it's not working. You collect more data, it's not working. Then there are these kinds of feature manipulations which the algorithms actually cannot do. Like normalization. Maybe you divide one feature with another feature in a meaningful way. If they have some meaning, that's something
Okay.
algorithms can do.
Give me the words, I'll look it up.
So
Normalization.
look for feature engineering.
Yeah, these are all standard feature engineering.
Yeah.
Normalization and feature engineering.
Yeah, just go ahead and
Okay.
research that.
Another stupid question for a mathematician.
Please.
Okay. You know the problem of incorporation, right?
Yeah.
A, B, C, yeah. And we have fit in a straight line, we have fit in a curve.
Mm-hmm.
Okay, huh?
Mm-hmm.
AI apparently has a similar issue. They have called it the
Regularization.
variance and something like that. Like
Overfitting.
what we call in overfitting versus underfitting from mathematics.
Mm-hmm.
You have a different term for
Yep.
that.
No, it's actually called overfitting.
It is called overfitting.
Variance and something like that.
Bias and variance
Bias
of
and
the
that's the equivalent in AI. Okay.
Mhm.
So we also get stuck into that problem is also there in AI, right?
So that's where what Nisha said comes in. Every algorithm can be run in a very different way by tuning its hyperparameters. When you tune the hyperparameters,
What hyperparameter?
hyperparameters.
You should write that one down. That's a good one to write down.
Hyperparameter. Okay, I'll Google it and
So
get it.
these are more than the attributes.
No, these are not the
This is
attributes.
not
These are the
attributes.
parameters of the algorithm
Algorithm.
itself.
Basically, y is equal to x1, x2, x3, y2 is equal to x1 to like that, right?
Not quite.
No.
Basically, from a mathematical point of view, huh?
From a
Why-
mathematical point
No,
of
not
view,
that
think
even.
about it as, let's say it's a regression problem. Y is equal to x1, like what you were
x1,
saying.
x2, x3.
But the objective function is not just that. So you have that, plus you have a regularization value lambda, which is weighing the weights. So which means if your weights are a very large value, then it makes the objective. So it's like a trade-off between how big your weights are going to be
Yes.
and how it fits your model.
Okay.
Right, so what will happen is then you're going to say y is equal to ax plus bx square,
Yes.
right?
Yes.
Then what are you trying to minimize? You're trying to minimize y minus ax plus bx. You want it to be zero.
Yes,
But
right.
instead of minimizing that, you don't do that. What you do is you take that and you add a regularization term to it. So you say plus lambda of my, norm of the weights. So what you're essentially doing is if my weights are a very large value, then your objective is going to be really huge. If my weights are a really small value, then you're doing a bad job of prediction, even though you're going to. So it's like a trade-off between these two.
Yeah, so basically the first part of the equation is basically the standard way what we do, what mathematicians do.
Mhm.
Find the distance of the point from the line and minimize that, right?
Mhm.
But you're saying instead of taking that number, you add something regularization, right?
Mhm.
Okay, I'll Google this.
That's
out.
just one example. Every machine learning algorithm has its own set of hyperparameters that you can optimize.
Okay, so this word just think to look up our normalization, regularization, hyperparameter, and
Yeah, so let's get, how about this?
We
Let's keep
I'm
going.
sorry, I'm sorry.
No, let's keep going.
I'm sorry, very sorry.
So why don't you go ahead and do the demo?
So I'm
Yeah,
going
sorry.
to disconnect.
Yes, I can disconnect.
Will it stop recording?
It will not stop recording, but you will need to share on the
I'll share,
Zoom, and
But
then it
I'll
will
use
record.
your audio.
Yes, by all
Okay.
means. Please go ahead and use my
So
audio.
that's the simplest way to do
Yeah.
it.
And I also just, Ravi,
Yeah.
Ravi on the conference call, I just replied to your question. If you have
Yeah,
an
I'm looking at it. Thank you so much. But one quick question. So when you're training your model, right? So when do you really stop? I mean, ideally speaking, for any business practical problem, you'd want to have almost close to 100% accuracy, although we never reach 100%. So, if your data and the model is reaching you around 90%, and that's not acceptable, then when do you really stop? I mean, when you run out of data because you cannot tune it anymore, or like, what's the general best practice?
So the algorithms typically have a stopping criterion, and the stopping criterion is when they have converged. So convergence means that with every subsequent run, they're not really getting any better. So they've done the best that they can. So that's usually when the algorithms stop. There are other ways to stop them by things like runtime and such, if you are constrained. But if you're looking for the best accuracy that the algorithm can deliver given infinite amount of time, then the stopping criterion will be the convergence.
Okay. And then basically, if you, let's say you're targeting for 99% and the algorithm that you choose only takes you to 90%, that means, does it mean that we should pick up another model, or does that simply mean that, once you have reached the conversion, obviously that's a, deadlock scenario, but so do you think you should look for another algorithm to tune it?
A couple of different things. So there are a number of things you can do in the order that you should probably try to do them. The first is to try to get more data. Second is to try to fix your features and see if you can clean up your features and make it easier for the algorithm. The third is to tune the parameters of the algorithm themselves. If none of that works, then you should probably try another algorithm. The other thing that you'll learn as you try to do practice is that there are some algorithms that are just very, very robust. So think of them as, in the land of AI, there are these workhorse algorithms. Like, they're not awesome, but they are good at many things, and they're kind of hard to get wrong. And then you have these highly temperamental, they're kind of, I don't know, I'm going to use a horrible. The workhorse ones are random forest, linear regression, logistic regression, and if you must do deep learning, CNN.
Just repeat again the workhorse one, the what?
Linear regression, logistic
This is the name
regression,
of the
algorithm. Logistic regression, XGBoost.
Wait, fast, not so fast.
You'll see it in the demo. It'll be in the demo. Yeah, it'll be in the demo. No, please. Just write them down. You're good.
Linear regression.
Linear regression, logistic regression, XGBoost.
Wait, logistic regression,
XGBoost. Boost.
BOOST.
Okay, G-boost.
Random forest.
Yeah, random forest is a good one.
Okay. Anything else in the workforce arena?
Oh, this should be good too.
Yeah,
Non-deep
That's
learning.
good, that's good.
Yeah.
Workhorse. And what are the temperamental ones?
There are too many temperamental ones. It can't
Name
possibly.
C.
Everything else pretty much is temperamental.
Name
So
C at least.
Huh?
Name C as something you can Google and read.
generalized adversarial networks. Enjoy. GANs. Reinforcement learning. Deep reinforcement learning. You're looking for trouble, you can find it in any of those three places.
Deep reinforcement. Okay.
Yeah, please stick with the workhorses.
Another stupid question. The one that we use download from Google, TensorFlow, which algorithm does that?
It's usually deep learning.
Use-
It's none of those.
It's none of those. There are too many algorithms. It's not any of those. And TensorFlow is not an algorithm. TensorFlow is a piece
No,
of
for
code
products.
it's a product
Yeah,
that
but
runs
one of
many.
them, what algorithm does it use?
We have no idea what you used.
Okay.
It's not possible to know. So, okay, so let's get going.
Then you're going
Yeah, so, yes,
Can these be used for multiple types of
yes,
problems?
yes.
Each of them, okay.
yes. That's what makes them so cool.
Okay.
So,
What was the question?
can they be used for
Can these workhorse algorithms be used for multiple types of problems?
Yes, they can be used for multiple types. So I think I was in the process of answering the gentleman's question, which is, look, workhorses, they may not get you the perfect accuracy, but they're solid and it's hard to get them wrong. The temperamental ones will get you to 99%, but you need to stay on top of them because when they explode badly. So that's the trade-off. So the question is, how much do you want 99% and how much is the extra 5% worth for you? So, and that's a question you have to answer for yourself. Go ahead, Sindhu. So we have 25 minutes left. Let's run through a demo real quick.
Wow.
Yeah, I know. So
It's gonna be hard. So anyway,
we'll do it.
so yes, we'll do it.
You bunch of newcomers, you're going to get stupid questions.
It's okay. We're good. So you can do this demo yourself also. It might be a little bit tight, but the way to get yourself an account on it is you go to aiclub.world where you can sign up.
AIClub.world.
I'm going to write it there over there so that you can have it. So that's where you get your free version that you want to try out. Okay.
Evenco.world.
AIclub.world. Go to there and sign up.
Is it inside a?
Yeah, this is our products community site. It's a community site.
Oh, there is a .world domain.
Yeah, it's a .world domain.
Yeah, the picture is from some antivirus or something like that.
I can't look at any of these things.
Your website,
Thank you.
Pixela,
Oh, no, it doesn't have.
is from Antigua or some island from the.
No, it's not. No. Okay, here we go. Okay.
Oh, he's pretty
All
very
right.
clear.
So you can sign up and get an account. So what will happen once you sign up and have an account is Navigator is going to appear over here for you. So sign up is really quick. All of you can do it, even right now, and it will get approved. So then something called Navigator appears here.
So this is the one, we'll go to the webpage, this will come, right?
This will come. So
What is it?
go to the web page and sign up. And if you sign up, then this Navigator will appear. When you go to the website, you will not see a Navigator icon over here on the top right side.
Okay.
So once Navigator appears, you can click on it, and that will open a tab that looks like this. Okay, makes sense. Now, if you have your own AWS account, right, where you have your data set and you want to use your own AWS account, then there is an option to go into settings. And here you can click on AWS. And there are step-by-step instructions on how you can, link an account. In my case, I have already linked this to an account, to my personal account over here. So that's why it shows me that I'm already linked. But if you're not linked, when you go to settings, you see these tabs of different clouds. You just click on AWS, and there are very clear step-by-step instructions on how you link your own account. And you will want to do this because when you're building your own production, you obviously want it running in your own AWS where your data is. Maybe you don't want us to see your data, or like whatever it is. Like, if you want to use your own AWS, feel free to do that.
But to play with it, you don't have to do that.
To play with it, you don't have to do that. No. If you don't want to connect your AWS account, that's fine. It's still going to work exactly as how it would work if you had connected it. So now let's get started with creating a service. So you can see three main tabs here, right? You can create a service. If you already have a service, you can retrain your service, or you can simply go to one of your existing AI services. So let's start from scratch where we are creating an AI service. So the first thing you do is just give it a name. So I'm going to say startup service. Okay. So I have created a service. I have started creating a service. So now it asks, what do you have where would you like to start, right? So I'm going to say I have a data set, and that's where I want to start. Now, where is the data? So remember, I selected AWS as my link up, right? So simple storage service is how AWS stores its data. It's like a folder thing that you have. Now, the data, so you can do one of two things. If you have your data in your laptop, right, you already have a data set, then you can just upload it, click on upload, and you can select one of the data sets, from your laptop. Or you can go to simple storage service where your data set, let's say, is not on your laptop. It's there in S3, in your own S3. Then you can go to S3, and here all the buckets that are available to you will appear over here. So you can select one of them and start running with it. So so this is when you have it. So I'm going to show you how it works when you have it on your laptop, for example.
What kind of data does it take? What formats?
So right now it takes only a CSV. So I'll show the data actually. So let's say I uploaded this data. It was on my laptop. I just uploaded it. So then the next step is to import this data set. So upload gets your data set into the cloud. And when you click import over here, it's just showing you a small snippet of the data set. This is how the churn data set looks. So let's spend a little bit of time just looking at it. So these are all the columns it has. The credit score, age, tenure, balance, number of products, if this person has a card, if they're an active member, what's their salary, and exited is the field that you want to predict. Is this customer going to stay, or is this customer going to leave? Now, if you have your own data set, it has to be in a structure where you have all of these columns. Each column is a feature.
right? And then you have one column which you're really interested in and you want your AI service to predict. So that column is called a label. And rest of these are called features. Every single row is a new sample. So when you're collecting your data set, what you need to keep in mind is your AI service will expect you to provide a credit score, age, tenure, balance, and all of these features. And as a response, it's going to tell you if this person is going to exit or not. So for your particular problem, whatever your problem is, you need to first decide what are the things that I can provide to my AI service and what is the answer that I'm expecting from it. And that's the data that you need to collect so that it can learn patterns from it. Now you can optionally explore this data and it will tell you what is the range of it, what is the mean value, what is the variance value. So statistical exploration you can do if you click on explore data. I'm not going to do it right now because we are a little bit short on time. But you can feel free to go ahead and do that on any data set that you would like. So far, what have I done? I just uploaded a data set, that's it. My AI service doesn't know anything about what to do with it. It just knows that it has a data set. So the second question it asks you is, what is it that you're trying to predict? So in this case, I'm trying to predict if a customer is going to exit or not. So that's what I'm going to select. In your case, for your data, whatever column you want to predict, you select that. And then here you click apply. This is where we do some amount of feature cleaning or cleansing. So we prepare these. So we not only do cleaning, we do a lot more things in the background to make sure that it can be trained by an ML algorithm. So first thing is identify a problem, right? So we analyze. So you told me that I want to predict if a customer is going to exit. So I analyzed that column and I decided that this is a binary classification problem. Now, how did I decide that? You can click on details and, learn how that was done. There are a lot of things that are done. You can always click on the details button and it will tell you why it was done. Why is rearranging being run? Why are some columns dropped? Everything about everything going on internally, you can just click on it. So I'm not going to go into the details of everything over here, but these are all basically the steps that we take in order to make sure that your data is ready for training by an ML algorithm.
Yeah, so and the key thing here is that, so if you look at the decisions that it made and the order in which it made them and how these are the decisions that you would need to make yourself if you were trying to connect up the tools. So it's not just about connecting the tools, it's also about knowing when to apply. And so what has happened here is it has looked at the data set and what you want to do and figured out what type of AI is needed. And it has cleaned up the data set to make the data suitable for that type of AI. So that's the kind of thing that makes it more accessible to people who don't have data scientists on staff. This is the work that the data scientist would normally do. Go ahead, Sam.
So how do you decide that you have to drop this value? So do you have an algorithm there? And that is configurable, right? If you want to drop this
Yes.
one, do something else.
Yes. Yeah.
Feature.
Yes.
Let's say that you had a feature which had all URLs. That's not useful for an algorithm to learn, so it will automatically detect that and drop it. So things like that. The last step is where you split the data into training and validation so that you train using a portion of the data and then you calculate the performance on the rest of the data.
That's the final exam.
Yes.
Yeah,
final exam.
yeah,
The final exam,
It
yes.
will prepare the final exam for you.
Yes.
Can this do like more complex problem?
More
Like,
complex in the sense.
For example, if I have like a list of customers and then I import it in there, so it analyze like who's the customer characteristic and then we learn from there. And then I have also like the email list or other kind of like who hasn't made a purchase yet. Like I also have this data. So can you predict like what percentage of the people or more, what people in the email list like they can like more intend to purchase so that I can like specifically market to them so they can like,
Yes, it can do that.
Absolutely, yeah.
It can do things like that.
It
Yeah.
can do things like that, yes.
on this platform.
Sure, yeah. So the difficult part is not learning to do that. Learning to do that, this platform can absolutely do. You are cleaning up your data, so to provide it with initial training, there will be a little bit of work that you need to do to create that CSV for it. But after that, yes, it can do really complex things.
Okay, what do you mean like you have to like prepare data and how long does it take for them like for the platform to learn
Oh, the platform doesn't take any time. It takes like
10 minutes.
Yeah, 10 minutes maybe to learn.
Okay.
So the complexity of learning and all has been figured out by the platform, so it won't
So
take you
even
any
it's a
time.
huge list.
It doesn't matter. Yeah.
Okay.
It's fine. Yeah.
It should be okay. All right. So now we come to the training part of it. So we have cleaned the data, prepared the data. It's ready for training. So I'm going to stick to automatic today, but for someone who knows what these algorithms are, there is a semi-automatic mode. You can go into it and configure hyperparameters and do all this. Let's not go into that today. So I'm just going to click train on automatic. So what is this going to do? It's going to do three things for you. It's going to pick a bunch of algorithms which are suitable for the data that you have uploaded. It's going to compare their performance. In this case, since it's a binary classifier, it's going to compare the accuracy values. If it was some other algorithm, it would have had some other metric to compare.
It knows how to create the final exam in the right way for the different algorithms.
For different algorithms.
Yes.
And then it will pick the best one and deploy it for you.
So how would you pick the last 20 or last 10% or the final exam?
It's random, it's shuffled.
Separate. And then take the 20%. How much? 10%, 20%?
20 by default.
Huh?
20.
20%.
Yeah.
The 20% you take it for.
Sorry, you had a comment?
That also depends on the data, how you pick it, right? There's something about if there's a temporal aspect to it, you have to pick the
It
data.
depends on type of data.
Yeah, if it's a
Yeah.
temporal aspect, then you pick very differently. Absolutely. Yes.
So this is going to take about 10 minutes to train. However, I do have another AI service running, which I had trained right before. It's the exact same.
And it says it's
example.
going to take about 10 minutes.
Yeah, it's going to take.
So those are the 4 that it picked. And if you look at it, 2 of your workhorses are in there. XGBoost and linear learner, which is linear regression,
So the
basically.
important thing is that for the data, right, you can train it using different algorithms. So instead of you manually trying out different algorithms and seeing which one is good, the platform automatically selects the appropriate algorithms for you and then trains on all of them in parallel.
And then it picks the best one.
Yes.
It picks the
And
best
then
one.
which exam has passed?
Yes, exactly. It will rank all the algorithms based on your.
How many marks you got out of 20?
You'll see that. Yes.
Okay, I can show you one
How many
example.
marks did you get out of 20?
It's
I'll show you. It's running. It has. We don't know yet.
I have some previously trained, so I need to see which one it is, though I have too many services running. Is it this one?
So
Yeah.
there, see?
So here are the, so once it finishes, right, it's there for you to go back and check anytime. So if you look at how it performed, I'm sure the performance will be exactly same on this one as
This
well.
is 95% mark.
No, 85.
I can see it probably.
Yeah.
85%.
So the best one did, yeah, the best one got 85.6%.
Pretty good.
Yeah.
A grade.
Yeah. So,
Can you
And
export
these
the
are-
model?
Xboost.
Yeah.
Can you export? your
yeah.
model?
So if you have the, if you've connected up your AWS account,
Mhm.
the model will be in your AWS account.
What format? How does it?
It's the native format AWS uses, and it's usually different by model.
So basically, all this execution is running on our AWS.
It's running on your AWS account.
You are just providing a front end.
We're providing a front end. So everything you create is available for you on your AWS. So you don't have to, so think of it like your data is going to be on your AWS anyway, because that's where you build your startup. The data never leaves your AWS. So everything is happening in your AWS. It's just so much easier to deal with it.
All the 3 cloud providers supported.
So we're adding support for GCP right now.
Okay.
And then after that, we will add Azure. So we're slowly adding that.
AWS.
AWS is first.
A quick question.
On a mathematical point of view. Okay? So y is basically y is equal to x1, x2, x3, x4, x5, x1, x2, x4, x5. What are the attributes, right?
No. Yes,
Yeah.
maybe.
Depends on how he.
Depends on what he means by X.
Oh, yeah.
Okay, fair enough.
Okay, let's say that in your
Let's go
case
with
that-
that.
So basically, at the end of the day, y is going to leave or not going to leave, and is a function of x1.
Yeah, that's fair. That's fair.
X1,
Yes.
A function of x1, x2, x2. Right? Now the function, what you're doing is the training is to create that function.
Yes, that's correct.
Create that function, and then you are using those 20% data to see whether the function passes the thing or not, right? And the training model is the function.
That's correct. Yes, that's
Yes.
So just to kind of
The
help,
same thing
also
is
help you guys,
figured
to help you guys understand sort of the relationship between AWS and what we do here. So if you look at this, the data came out of AWS. The training job ran on AWS. The model will be deposited in AWS. However, the cleaning process that prepared your data is code that we wrote that's running as part of our tool. The decision on how to map the right algorithms to your data came from our tool. So those are the kinds of things that you would have to do manually if you were doing AWS. So it's kind of like, imagine if there was an automated, it's like say a data scientist was using AWS to solve a problem for you, and we've replaced that data scientist with a program. It's still your AWS and your artifacts, and everything lives there.
And do you have a fixed set of algorithm that you pick from? Let's say if there are newer algorithms coming, do you have any dynamic way of refreshing those in your tool, or they are static set and then,
Yeah, so right now we have a fixed set that we're adding to, but one of the features that we're adding is the ability for you to bring in your own algorithms in a container. So, so then you can bring in any algorithm you like, including algorithms that you might be able to get from the Amazon Marketplace, for example. So we don't have that right now, but it's something that we're adding.
But semi-automatic.
Semi-automatic allows you to configure what's there. Eventually semi-automatic. So right now, semi-automatic as it is in this release allows you to configure what's there. But a future feature on our roadmap for semi-automatic is you can containerize. So imagine package your own algorithm into a Docker container. You can drop it in.
So now the question is, see, it's already graded your algorithms based on the data set. It identified which one is the best, and it'll automatically deploy your best algorithm into production so that you can use and ask questions for that.
Okay.
And then I think Sindhu is going to show you a deployed one.
And all these XGBoosts, these algorithms are part of AWS.
These are AWS versions, but we mix and match. So we are adding our own versions as well.
Okay.
So this is going to deploy most likely in the next, 5-10 minutes. It will deploy and you'll have a REST service with it. Once you have a service, you can use our UI to interact with it.
Yeah.
But you don't need to use just our UI. You can use some external tool like Postman. Is everyone familiar with Postman?
Yeah.
It's one of the popular tools that's used to interact with a REST service, right? So what you do is you post this URL. How did I get this URL? This URL will be provided to you by Navigator. I'll show you where to get it from.
So just to add to it, right, the idea is that once you have trained a model, it will be deployed as a microservice that Nisha mentioned earlier, that is publicly accessible, or you can protect it by a secret key that you want to connect to your app. So once that is deployed, you can use any tool or you can write your own application to connect to the service and ask questions.
How do you get the signature of the object you send?
We give it to you.
So once it's done, we'll give you that URL.
We will give you
Not
that.
just the URL,
The signature
the
also.
object
Yeah,
also.
I know what you mean. So let me, where am I? Okay, sorry. There's something called integration. Okay, and this is the URL you're seeing, which you can copy, right? Now, the signature that you were asking about, there are several snippets we provide. If I say curl, then this is telling you that there's credit score, age, tenure, balance. This is the signature, right? So I can do Python integration, for example. If I click on Python, this is the snippet I use. It also tells you the format of your response, so that you already know how it's going to look like to integrate with your application. There are several, it's very trivial for us to add any language here, actually. If you
look
don't
at
see
it,
your
look how
favorite,
short the integration part is, and all of this code is auto-generated for you. So this is the exact snippet for this AI service. So all you have to do is to cut and paste this thing into your code and be somewhere network reachable. It could be running on it could be an iPhone app, it could be whatever, it could be in a data center. It will talk to the AI service.
So one quick question, in terms of protecting it, so it's a protected asset for me, which I've trained, and I don't want anybody to just hit this endpoint and a public gateway. So how do I protect it?
Yeah, so Swami, you want to repeat?
We can actually provide, you can secure it with the access key, and with this request, if you provide an access key, or if you want, you can pick the whitelist of IPs that you want to ping it from, and we can add permissions for that actually.
So does it have any kind of OAuth integration, OAuth 2 integration, or any other?
We can definitely provide that if it's the requirement that you have. We don't have it yet, but we can add that. It's easy for us to add it actually.
Is that part of you do that on AWS, or you do it as
We
part
do
of, with
no, we
your
do it as
service?
part of AWS.
Yeah.
We use it to configure AWS in order to provide that authentication.
AWS will be providing it.
Yeah.
We will simply be configuring it on
But it could be configured through your.
Yes.
Yes, it can be
That is
configured
correct.
through our service. Yeah, it's a native AWS capability.
Okay.
So if you're running, for example, this kind of thing, particularly in a use case, and you would want to use authentication, or you would want to be making sure that your code is running in your AWS and it's the only thing communicating.
Mhm.
You know, that the flow
Yeah.
never goes out,
Yeah.
basically. So now you can see how, so this is one of the reasons why we advocate the microservice, is because the integration it enables a very powerful and very quick prototyping that you can use to test it out. And this also means that you can change your code as you see fit without this changing. And you can retrain this as you see fit without your code changing. So it gives you this ability to really create a very
So
clean.
your software as a service, it ends here?
Huh?
Or once user generates this model or something?
No, we provide monitoring and other things as well. So Sindhu will show you the Ask Your AI.
No, assume you don't want all those things. So you generated the web link for us, right? HTTP link. So your job ended there. Right? You can just.
Unfortunately, no.
No.
So the way to think about it, right? The learning never stops. You have to keep learning because your customer's pattern changes, your data pattern changes. So you have to constantly monitor and learn from it. Okay, you learned that president of US is a Trump, but in 4 years it's going to change, and in 2 years it's going to change. We don't know that. So when things change, you have to relearn again.
Correct, but at that time I will come again.
But how do you know that when to come
So
again?
basically, you prefer that it should be daily, like as somebody leaves, use that as a training data.
It depends on the usage scenario. Actually, for some people it may be daily.
So what happens is, think of it this way. Okay, so there are some, regardless of our tool, it's generally true that after you've deployed an AI, you have to come back to it for a host of reasons. And so there are several reasons. So one of them is that, as what Swami said, which is as data changes, you may find the need to retrain, and your frequency of retraining depends a lot on your circumstances. Some people retrain quarterly, some people retrain every 15 minutes. It depends on your situation. When you retrain, you most likely do not want to create a new AI service and a new endpoint, because that means that you've got programs running around that may or may not, you'll break everything. So you will decide whether you want to push a new model into the existing endpoint. So that's the most common approach, is that you create a new model, you push it to the existing endpoint, and then you keep a copy of the old model just in case you need to roll back. So that's one thing people do. Another thing that people do when they're more sophisticated is staged rollouts. So you might think that, okay, now, it's like you've gotten really big, you have 100,000 customers, right? You have a new model. You may want it only deployed to 100 customers, then to 200, then to 500. So you may want to do a stage rollout where you create essentially an A/B test kind of a scenario. So there's a lot of these kinds of things going on that are, so what people who have deployed models in production, what they find is that you can't just fire and forget the models. All sorts of stuff happens. Sometimes data changes that triggers bugs in the models. Like imagine like a simple example. Okay, say that you trained a model to tell the difference between a cat, a dog, and a giraffe. Okay, and it had 5 samples of giraffes. Suddenly, your real world, all giraffes. And it hasn't been trained. It has no clue what's going on, right? It predicts half of them to be cats or something like that. And so one thing is that if your real world does not match the examples, the model will behave badly. And when the model behaves badly, you're going to need to be able to tell that. And you're going to need to adjust it. You might want to roll it back. You might want to replace it with a static prediction just to keep you on the safe side until, you know what's going on. So unfortunately, deployment is not the end of your problem.
Good.
Will this eventually support the stage rollout? Like what you
Yes,
talked
we will,
about?
yeah. So stage rollout is something, the reason we haven't supported it right now is because most customers are not complicated enough to do that, but yes, we will.
How would you differentiate between say the 100 and then all the rest? Like how
So
would it
usually
be a different service or what?
there are 2 ways to do it.
Mhm.
If you want to control who gets what, it will be a different service. If you wanted to time multiplex it or you want to probabilistically multiplex it, there's multiple different ways that people do it. So usually you give the ability to configure. So one way to do it would be to say, okay, 10% of the traffic, any 10%.
Okay.
gets it,
Got it.
you know,
Mhm.
some based on some criterion, like one of those fields could be a criterion. So there's lots of different ways to slice and dice it.
Okay.
So, quick question. So in terms of tuning, right? So there needs to be some kind of feedback loop where, based upon the prediction accuracy, whether it is accurate or not, we want to say, hey, it's a time to retrain your model, right? So how do you have the feedback loop, rather than, you coming after quarter, or like maybe after half a year or year, whatever you decide. But if you want to have a continuous feedback loop where you are basically saying, hey, it's a time to retrain your model. Do you have any such thing?
We don't have it currently, but these are the kinds of things that I was referring to. So right now we are helping people who are just getting their first one started, but this is absolutely the right thing to add. And there are multiple ways to add it. So one way, for example, is if you go to Sindhu, if you go to the Ask Your AI, you can see how people, we have this online service where you can connect to your AI. And this is one place where you can provide feedback. Another place where you can provide feedback is to essentially retrain, with the corrected,
It'd be nice if you
entities.
could just load a new data set and just run it and see what the prediction was.
Yes.
Instead of one at a time. This does one at a time.
Oh, I see.
Yeah.
Okay, that's actually a good idea. Yes,
Yeah.
that's actually honestly not that hard for us to add as well. Actually, we have that in programs.
Then you could say, like, a month later,
Yeah.
give me this data set, is it still predicting?
I like it.
Yeah.
Makes sense. Yeah, that's very, very cool. Thank you. Keep that up.
So what is the thing? Like instead of continuous learning, you batch it. Like after 1 month,
Yeah.
what are the data that come in? And that's good. I mean, so and then do you incrementally tweak or you relearn everything from the beginning?
It depends on your situation.
No, but is it possible to incrementally?
It is possible to incrementally tweak some algorithms, not all of them. So there are some algorithms that lend themselves to incremental tweaking, some do not, and some you have to retrain from scratch. It depends on the algorithm, really. It's less an issue of us. It's more a question of, there are some algorithms that can actually take in a bootstrap model that came from another algorithm and then add to it. Some don't have natively the ability to do that.
It will start all over now.
So anyway, and I think as you were saying, I mean, you can see what the Ask Your AI is basically a way that you can explore, what the relevance is. It also provides you with a very easy web-based interface so that you have something that you can poke at. Yeah. But honestly, for people who are building startups, I think the higher priority is the fact that the REST service is just so easy to integrate. You can create a little Python program to query, talk to your AI anytime you want. It won't take you, more than 5 minutes.
A quick question. Have you seen a need for chaining different models? In your example, you're saying, let's say you're saying Boolean, yes or no kind of thing, and then you're done with it, right? You have created a microservice for that. But in a complex workflow, do you see a need where you may want to chain, multiple different models?
Yeah, it happens. They're usually called stacked models. And it is actually, people do that. People do that fairly often. So you can chain models easily in this structure you can basically just create a Python program that change your models together in any, either in a group, in a sequence, whatever, by creating multiple AI services, one for each model, and then you group them together any way you like. So you can create complex chains that way if you want. Chain models are less common than single models because people just aren't sophisticated enough yet outside of the big companies, but it is possible. You had a question, yes.
So in the results, right, I saw that XGBoost took the top place.
Yes.
RNN was in the third or fourth place. Usually RNN is supposed to be the
KNN, not RNN. This is not RNN.
Oh, okay.
This is KNN. It's K nearest neighbor, different algorithm.
Okay.
Not not convoluted neural networks.
No.
None of these are deep.
These are all
These are
machine learning.
regular ML algorithms.
Oh, so everything is regular. So there's no deep learning.
We're adding the deep learning as we speak. Yeah.
Deep learning is where there's more than one. What is deep learning? Basically, more than one internal.
Deep learning is a particular class of AI that focuses on a technology called neural networks.
Yeah.
Beyond that, I mean, they're very different. Yeah, go. Yeah, that's a very good idea.
Already, and I was too confused.
So, TensorFlow, whatever algorithm you were using there, it was deep learning. That was when you did your TensorFlow numbers exercise.
Yeah.
That was
It was deep learning.
So,
What kind of deep learning, I don't know, but it was deep learning. Angry.
Question, a quick one. So, do you guys have an on-premise model or it's all cloud-based? So basically, in this case, you know, you have integration to different cloud vendors and you have ability
Right
to.
now, yeah, so right now we're prioritizing the cloud model. We're not really focusing on on-prem at the moment.
Okay.
Yeah, so I think we are 7 minutes overdue. I am going to, so.
I stopped sharing.
Oh, you stopped sharing? Okay, I'm gonna share my slides for just a second and then going to share slide. If you wanted to get an account, it's right over there. Feel free to grab an account. If you are far enough along that you're interested in building a prototype, we do offer a consulting service. You're welcome to call us and we can, sit and walk you through your data and your, we have this process we call ideation, which is if you got the data, you're not quite sure how to map it to an AI, that is something that we can help you with. So these are really the two key things. As far as future meetups, there's a list of topics that that we included in the slides. I'm going to add the recording of this meetup to the meetups page so that you guys all have access to it, and that'll contain all the slides as well. I would like to have the next meetup in about a month and a half. So if you guys have suggestions on topics that you'd like to discuss, one good topic might be how you map a problem to an AI. Because that's an interesting thing in its own right. Like, if I have a data set, it looks like this, I've got zip codes, I've got this, I've got that. What kind of AI is that anyway? So I think that topic in itself might be of interest. Can I get a quick sense of people are feeling like that would be interesting? Okay, so maybe we should try to make that the next one. So that's all I had, folks, but drop us any questions if you need anything. Otherwise, thank you so much for coming. And folks online, thank you so much for coming.
Thank you.
Thank you.
Very nice talking to you.